Tales de Mileto fue un filósofo, matemático, geómetra, físico y legislador griego. Aristóteles lo consideró como el iniciador de la escuela de Mileto, a la que pertenecieron también Anaximandro y Anaxímenes. Fue el primero en decir que la Tierra flota sobre el agua y por ello lo consideró el origen de todas las cosas. Tales explicó que el principio originario de la naturaleza y de la materia era una única sustancia última, el agua.
Thales calculated the height of the pyramids using the theorem of Thales, which consisted in measuring the shadow of the pyramids in comparison with its own shadow and applying a geometrical proportion. The shadow is the region where the sun's rays do not hit. It is assumed that the rays hitting the pyramid and the staff are parallel, a consequence of the great distance separating the sun from the earth, and the staff is stuck perpendicularly to the ground. Because of that, the angles of the two triangles shown in the figure are equal to each other, and therefore these triangles are similar. In two similar triangles, is it true that their homologous sides are proportional? In our case, it is true that the shadow of the pyramid by the shadow of the stick equals the height of the pyramid by the height of the stick. Thales substituted the data and got the approximate result of the height of the pyramid, which was 149.34 meters. The pyramid he measured was the pyramid of Cheops.
We want to know the height of a lamp post. We will place a mirror on the ground lying face up, at a now distance from the lamp post. Now we are moving away without stopping looking at the mirror, until the top of the lamp post appears reflected in it.
When we take the measurements from the mirror to the street light and from the mirror to the person, we apply the formula of the theorem of Thales.
In this exercise, we have to calculate the height of a monument. In our case, we have chosen a lamppost using the method of the mirror and the different measurements of the members of the group. We have a board when we can see the height of the person, the distance between the mirror and the lamppost, the distance between the mirror and the person, and the final height of the lamppost. First, we have done it with my measurements, and we have obtained that the lamppost measures 3 with 87 meters. Then we have done the same but with the measurements of Isaiah, and we have obtained that the lamppost measures 3 with 84 meters. And finally, we have done it with Tanya, and the lamppost measures 3 with 7 meters. We add now the data of each result and divide it between the number of results, which is 3. It gives us an average of what the lamppost measures, which is 3 with 8 meters high.
To carry out exercise 4, we must obtain as essential measurements the distance from the person to the object, in this case, a lamppost, the height from the feet to the eyes, and the degree that the eyes form with the head straight when looking at the top of the lamppost. We need to obtain the height of the lamppost, so we use the formula h equals distance times to the tangent of the angle, plus the height of the person. We substitute the data and solve the math to get the height. With Hema's measurements, the solution gives 8.39, with Isaiah's 8.60, and with mine 9.98. To obtain the average that will give us the final height of the street lamp, we must add up all the results and divide them, in this case, by the number of solutions, which is 3. The final result is that the street lamp measures 8.99 meters long. The conclusion is that the final height of the object is the average of the solutions previously obtained, but since the third is wrong, we can solve it. In any case, the lamppost goes around 8 meters and a half.